Let's start. So it's 5:30. Welcome to this meetup. It's the second series of open source data infrastructure meetup hosted by Ivan and Irori. And all these meetups that we host, they are like governed by Ivan's code of conduct. So if you see anything that you'd like to address, just shout out to me or come to me, and you can also escalate it on that email address. Okay, so for today, we will have a quick introduction about Ivan and Irori, and then we have two talks, one by Hamed about Postgres high availability and Kubernetes using Helm charts, and the second talk would be about providing easy-to-use platform capabilities by Jonathan. And after that, we will have mingle, food and drinks, and basically the networking. A quick intro about Ivan. So it was founded by 4 frustrated Postgres contributors to the open source project, that they were saying like they have to do all these solutions for disaster recovery and security and access control over and over again at every customer they went to. So that's the idea of Ivan platform actually comes from. And the idea is to have this open source technology in the different categories of streaming, like Kafka, storage, like Postgres and MySQL, and also in analysis category, like ClickHouse. So we make this open source technology available on our platform to be easy to use for the developers, but also being reliable for production. And we also have our open source office. So every improvement that we do to these technologies, we also add them to the upstream projects with the open source community. And with that, I guess I give it.
Yeah, and you are more varied. Sorry.
Yeah. Yeah, I'm more varied than I'm solution architect here at Ivan. Sorry, totally forgot about that.
No worries, no worries. Hi everyone, my name is Eric Forslid, and I work in business development at Irori, and I hope you guys are as excited as we are for the event tonight. But just some quick words about Irori. So who is Irori and what do we do? So Irori helps a company with everything from cloud establishment to and automation for infrastructure to middleware, all in order to realize. I think we have 2 people that looks missing. Andreas, kan du öppna dörren och kolla om de... Exakt. De gick till vänster där, Micke, tror jag. Kolla om de, för de har gått fram och tillbaka 2 gånger. Sorry guys. And even though these layers are separated areas of concerns, they are interconnected and depend on each other. And I guess if you use more, academic words for what Irori do, you could say that we do platform engineering and system integration. And today's meetup will focus on this lower and on the lowest level in the pyramid, platform automation and developer experience. And to sum in, if we zoom in here, we have a picture here of some generic platform capabilities. And while DevOps is great, it doesn't mean that everyone needs to ace the full stack. And Irori helps organizations master their cloud initiative with strong platform team that focuses on different platform aspects as their product. But enough about that. If anyone have any questions about Irori or is curious and have questions, let's talk more afterwards. And again, warm welcome everybody, and welcome up, Hamed.
Thank you.
Yes. Yes.
Hello everyone. My name is Hamed. I'm a DevOps engineer at the Cinch. Maybe you hear about that, but Cinch is a communication system between customers and companies. I'm a part of real-time communication system. And my day-to-day job is maintaining a Kubernetes cluster on AWS, using some cloud stuff, writing a Golang code, .NET, most of the time bash script. No, it's a part of our job. Yeah. And today we want to talk about that, a little bit about PostgreSQL, a little bit about high availability architecture, what's the high availability, and Kubernetes and Helm chart, and what's the alternative for this, and why we should using a high availability Postgres and Kubernetes and something like that. Okay. First, we want to talk about understanding high availability. Why we should using high availability. What's the high availability? And you hear a lot about high availability, and maybe somebody knows what is it, somebody not. And why Kubernetes is good for high availability, or what's the alternative for Kubernetes? And using the managed Kubernetes like HAS, EJS, or using the self-host, using the bare metal servers or something like that. And what's our challenging for in PostgreSQL HA? And how can we deploy it on the Kubernetes? Definitely, at least today we want to talk about Helm chart, but we want to little bit talk about alternative options. And this is my favorite part: monitoring and metrics. If you have a good monitoring and good metrics and good alerting system, definitely you have a really good system. Yes. First, high availability. Anybody? How many people hear about the high availability and have experience with designing high availability system? Good. Yeah. And why we should using the high availability? At first, for example, we have some servers. We want to design some high availability server, high availability system. At first, we can't. Yeah. At least you should have more than 2 servers. I don't mean physical servers, or bare metal or something like that. It can be a VPS, it can be EC2 instances, it can be a Azure VM or any servers. Why? Because if one server is down, we should have some reserve or backup plan for this. And for uptime, yeah. For this reason, we should have a high availability system. If you want to buy some service from somewhere, for example, you want to buy some Postgres service from some companies, and they tell we have a 90% uptime, and you have more than 1 month down. You can have more than 1 month downtime every year. Is that work for you? Definitely not. How about 99%? It's like a 4 day per each year. If you have some e-commerce application, maybe it's good for you. But if you have some, something like Sinch, it's a real-time communication service. If WhatsApp down for 4 days, 4 years, definitely you should Telegram. Anyway, you should use a Telegram. That is WhatsApp. Yeah. How about 99.99 or 99.999? It's really important, Let's see. For example, you want to buy some services from Azure. You have 2 choices: this one or this one. This one is cheaper, but this one is more expensive. Why we should use this one? If downtime is important for your business, you should buy more. You should have a more SLA level. It's a service level agreement between companies and cloud provider or something like that. But if it's not important for you, you can buy some services with lower SLA. And this is a concept from Google, SLA and SLO, service level agreement. Okay, let's talk about approach or design for high availability. We have 2. We will talk about 2 approach: active, and active passive. This is an active passive approach for high availability. For example, we have some WordPress service. It's a blog or something like that. We replicate it on the 2 server, and it's a sync service. We have a primary instance, and all users and the requests. For example, we have some WordPress. It's a blog WordPress, and they try to read some article or something like that, or something happens. The disk is full or something like that, and this primary server is down. What's happened? You get a 5x6, like 503 or something like that, or some Cloudflare page or something like that. What should we do? We should switch our IP on Cloudflare or any services to route all requests to the failover server and switch the failover server to primary server and try to fix the server number 1 or primary. Okay, it's worked for some e-commerce application or blog or something like that. We have a more downtime, but we spend less money for our engineering team or services or something like that. But how about active procedure? For example, we have some load balancer. It can be a service, it can be some cloud services, it can be a CDN, or it can be some bare metal server hosted some Nginx or Tomcat or any service. They wrote a request to the two servers. It's both of them. It's active. They can load balancing traffic between server 1 and server 2, and both of them it's the same. For example, we lost server 1. Nothing happening. User don't feel anything. Maybe a little bit slower, but end of the day, both our services it's work, and user don't feel anything. But for this approach, we should spend more money. We should spend more engineering. We should spend more people to maintain, to develop, to anything for these services. Okay. Let's see. Okay, for databases, we have an HA database, and we lost some instances. What's happening? Do you have any idea? Nothing, because we have some active database, and if we lost one instances, it's not happening. It's like my day-to-day job. We lost the instances, and users don't feel anything, and like messaging, just see one instance is down, we see some alerts or something like that. For this reason, using a HA architecture. These days, usually using a cloud or some services and don't feel this stuff. But back days, if you're using the bare metal servers or something like that, most of the time you feel this stuff. Okay. Yeah, my database is filled, but it's HA. I don't care. Okay. How about Kubernetes? How many people here touch Kubernetes? It's really good, yeah. Yeah, it's a really awesome tool. It's a fancy, but if you have experience with Kubernetes, you feel this one. You should, every day you should work with Prometheus. You should do it with Argo CD, with runtime. Every 6 months we have some update. Maybe some of them it's break or your cluster. You should change your runtime, switch from Docker to Containerd and something like stuff. I get paid for this one, but I like it, but definitely it's hard. If you have no experience for infrastructure or ops section, don't touch Kubernetes for production. Use Minikube or K3S or something like that to learn about Kubernetes, but don't touch it, please. Yeah. Yeah. But end of the day, how Kubernetes works. Yeah, we have two concepts. One of them is a control plane, and one of them is a worker node. Control plane is like a brain. Decide to how should we route traffic, how should we keep the state, or something like that. Anyone here have experience in managing self-host Kubernetes? Oh, you're here. Yeah, because you should manage etcd. It's a data store. It's a key value data store to keep the state of the cluster. It should be control manager, a scheduler to schedule every task. API server, it's like really like these days web server to get the API, send a request, receive the request from worker nodes or something like that. And every worker nodes have some kubelet to managing CPU and memory, and kube proxy to managing the network under Kubernetes. But do we have any idea it's a HA or not? I think. Okay. Cool. Yeah. Yes. It's not HA because we have a single point failure. We have a one control plane. How should we manage this one? How should we have a Kubernetes HA? We have a more control plane. How about two control plane? No, it's not work because control plane is like a Switzerland. It's voted for everything. No, some requests voted. If you have a two people, it's hard to decide. But how about three? Yeah, usually have a three control plane. How about four? It can be happening same as a two. But how about five? It's work. But how about seven? It's super slow. Never try seven control plane. How about worker node? We hosted the pod. If you hear about that, it's like a Docker container on the Kubernetes. Each pod can have how many much container that you want. 2, 3, 7, 10. They hosted your application. For example, you have some Spring Boot application. You to connect to some Kafka. You have some Java pod. They have some Java container. They hosted the Spring Boot, and they have some Kafka pod or something like that. They connect to each other, and you have replicate the pod. If some pod it's failed, it's a HA. You don't feel anything. Same as a Kafka. You can replicate the Kafka pod and something like that. Okay, build your own Kubernetes service or use the managed Kubernetes service like Amazon EKS or Azure AKS or Google Kubernetes Engine or DigitalOcean Kubernetes as a service. What do you think?
It depends.
Yeah. If you are some military company, some banks or something like that, you can't trust the Amazon to host your data. You should build your own Kubernetes service, but you need too much money, too much engineer to manage your Kubernetes because it's hard to manage your Kubernetes. You should be careful for piece by piece of your Kubernetes. How about manage Kubernetes? You just need some Terraform or AWS CDK or any infrastructure as a code, or go to your dashboard, click some button. Okay, now we have some Kubernetes with how many control plane nodes and how many workers nodes I want. Yeah, it's easy, and it's easy to manage, but you should pay more money for cloud, but not for your for your engineer. It depends. Okay. How about managing a Postgres HA on Kubernetes? Okay, first, let's talk about Postgres HA. It's an awesome database. We have someone here to develop some gateway for databases, especially for Postgres. Yeah. Okay, this is the really legacy usual HA architecture for any databases. It can be Postgres, it can be MySQL, it can be any SQL. Okay, first we have some primary instance. And we have some reserved instance. For example, we have some Java code. On the Java, we connect our code to this primary IP port with username and password and something like that. And this code have a read and write access to primary instance, and only have a read access to reserved instance. Okay, works fine, but something happened. Like OVH a couple of years ago, you lost your VPS on OVH, and your database is burned on the fire. Yeah, literally. Yeah, they lost some data center. What's happening? You should change your connection to your reserved instance and promote your reserved instance to primary instance and get the right access to your database. It takes time. It needs action. There can be some automation script or something like that, but it's easy to maintain. You don't need to write some script. You don't need to hire some on-call engineer or something like that for managing this stuff. But end of the day, it's not a HA because you need some action. Okay, let's talk about pgpool. It's tools that can help us to manage our PostgreSQL. They can be a load balancer, they can be a limiter of connection, they can be a switch, they can be promote your reserve instance to primary instance and something like that. But yeah, it's a tool. You can use this one to have a HA database. For example, you have a Java code. You connect to this PG pool instance, not directly to database, and send a request. For example, I select any rows with date, with some range date. It's a heavy select. They can be load balancing the traffic, for example, 50% on this node, 50% on this node, or it's not the same. They have, for example, this one have a 2-core CPU, this one have a 4-core CPU. 70% on this one, 30% on this one. Yeah, it's a good. They have a HA database right now with helping this awesome tool, PGPool. But it's not HA end of the day. We have a single point failure. We have only one single instance. We have only one instance of the PGPool. Yeah, this is the real HA. Yeah, we have a 3 instance of the PGPool and something called virtual IP. Anyone here know about virtual IP? Oh, yeah, that wasn't here. For example, we have some internal IP address. It's not real address. It can be point to any instances you want, like a service on Kubernetes. We have something on Kubernetes we call the service. They can be, it's a virtual IP address. They can point to any pod or any container we want. An application connect to this virtual IP. On your code, you set this IP address as a database, but it's not really it's not real IP. They can connect to this one, this one, this one, or something like that. Okay, we lost these instances. PGPool is smart and can detect if there are active instances lost. Automatically, they promote one of the standby PGPools to active, and they connect to the database. End of the day, user also or developer don't feel anything because it works it worked fine, but we lost some PGPool instances and nobody feel anything. How about our data? We lost one of them are, for example, primary or reserve databases. If it's a reserve, it's not really important because they have a read and write access on the primary, and reserve it's read only. If you lost a reserve, nothing happening. But how about primary? If you lost the primary, our code base cannot write anything on database. But PGPool is smart. They can promote automatically reserve instance to the primary, and now our code base can write on the reserve in former reserve, and now it's a primary instance. For this reason, we're using some tools like PGPool. Okay, now we want to deploy the PostgreSQL HA. Helm. Helm is a template based on Jinja 2 template. If you're writing some Python code, you run it with Jinja, but it's not right on the Python. Yeah. Anybody here working with Helm? Oh, what if you are some sysadmin? Yeah. Helm, it's a really good tool. It's for developer also, not for DevOps engineer, because it's easy to understand, it's easy to maintain, it's easy to modify. Also, we have some companies like Bitnami. I think it's come from VMware. They provide too many Helm charts. It's open source. It's also I have some GitHub link. Yes. Yep. This is the Bitnami Helm chart, and yeah, I cannot open the VS Code. Sorry. Yes. Helm chart. It's they have some main piece. One of them is a template. You can see it. It's some YAML file. We have some like PGPool. Yeah. It's for example config map. It's easier. Yeah.
Could you share the tab?
Okay. share this stuff. Yeah, thank you. Okay, this is a Helm chart. This is a template of the Helm chart. Nobody understands what they call, but you can see some values, but for example, values.xxx, values.xxx, values.xxx. Okay. What's the mean? What's the meaning of this values dot anything? Yeah. You can pass any variables here at the values file or replace it with another. Okay, another one. Sorry about that. Yes. You can modify this file and automatically replace these values to this template. And when you update or install a Helm chart on your Kubernetes cluster, you can easily have a PostgreSQL High, MongoDB, GitLab, or any services you want. I think for this reason, Helm chart is really good for anybody have a not that much experience with Kubernetes. They want to deploy a database, Kafka, web services, ingress controller, or anything, or literally anything. You can deploy anything with Helm chart. If they didn't exist, you can write your Helm chart, but you have you should have some experience with Helm chart. Personally, I recommend using a Helm chart for deploy anything on Kubernetes, because if you write your own manifest, you can't easily update your services. You don't have a clear path for update, for security patch, for anything. But if you're using a Helm chart, some companies care about that, and we only need to update to a new version. What's the alternative for Helm chart? Kubernetes operator. Kubernetes operator is, you can use the Kubernetes operator for deploy anything. It's based on, yeah. You can write a Kubernetes operator with Golang, with Python, with Node.js, with any programming language. It's not like a Helm chart. It's not a template. It's a really code base. Also, you can write an operator with Helm chart or Ansible or something like that. But it's a little bit complicated. But for some case, for example, you want to update your PostgreSQL password every 24 hours from AWS Secret Manager. You need an operator to read the data from Secret Manager and update it on some secrets on Kubernetes. For this use case, you should using your operator. But it's a little bit complicated. It's hard to maintain an operator, but sometimes we need to using operator on Kubernetes. Yeah, monitoring and service. If using a Helm chart, or we using a operator, or using anything, usually by default support the metrics. For example, on the Postgres, you have some exporter on your Helm chart to connect to the PG pool and connect to the Postgres. And also, the Kubernetes, you should deploy some monitoring stack like Kubernetes stack. It's included Prometheus metrics, Prometheus Alert Manager, and Grafana for dashboard. So yeah, he's a Grafana developer. Yeah. They pull the metrics from our cluster. For example, how much CPU each instance use, what's the workload for each instances, and push to Alert Manager. Alert Manager can write some rules on our Alert Manager. For example, if workload more than this person, I need get alert on Slack, Telegram, WhatsApp, emails, SMS, anything. Because you're using a webhook, you can call anything. Yeah. And our DevOps team, SRE team, or something like that can react on these alerts. For this reason, you should have a really good alerting system. For monitoring system, if anything happens on the system, we can see anything on this graph on a dashboard. It's easy to debug our system if we have a really good alerting and monitoring system. I think everybody here touched the Grafana at least one time. Yeah, it's awesome tools, but you need it. Yeah, not but yeah, you need it. You're using a Grafana. Yeah, and QA. Anybody have any question about Postgres? Yes.
it used to be a common wisdom that you don't deploy database instances in Kubernetes because you can't predict the available CPU and performance. Is that something of the past?
Something of the past, you mean before Kubernetes?
No. I mean, even in Kubernetes, you used to say that you install your database externally and call it from Kubernetes.
Yes.
For reliable performance.
Yes, you can do it. Honestly, it's the best practice to don't host any application with persistence data on Kubernetes. You can do it. You need some data manager or something like that to manage your data on Kubernetes, PV and PVC. But I don't recommend to host the database on Kubernetes, honestly. A database, any application have data. You can buy, it's easier to buy RDS or any database as a services and call it from Kubernetes or Docker Swarm or any application, because it's hard to maintain persistence data on Kubernetes. It's a best practice. Best practice is the host and launch any application without any persistent data on Kubernetes. For example, if you have some persistent data using a S3 or using a RDS or using any database as a service or Mini or something like that, I honestly, based on my experience, I don't recommend hosting a database on the Kubernetes at all, especially on the self-host Kubernetes.
There are some solutions.
I know that people do that these days, but
Yeah, so like there are some operators like Tembo recently and many others. So they are trying to solve the problem, but yeah, it's just.
You can using OpenEBS or something like that, but at my previous job, I using OpenEBS to managing the data on Kubernetes for PostgreSQL HA, using a economy object. But you know, sometimes if you have a serious incident, maybe you lost some data. You should have a really good backup plan. You should have a really good incidents recovery. But you know, you should pay more money and you should pay more risk or something like that to using a database on the Kubernetes. It's easier to buy some database as a service or something like that. For some case, like a military application or banking system or any system they can't trust the cloud provider, yes, you should use the OpenEBS or something like that, or some operator like Tempo.
Question on the metrics for uptime.
Okay.
You were mentioning some nines there. If we
Yes.
imagine there was a security incident in one of the major providers in Sweden recently.
Okay.
You know probably which one I'm talking about. But then it's on the application level, I imagine, or
Okay.
some security breach, something got encrypted, whatever. I don't know what
Yes.
happened exactly. But when you're measuring the nines, are you measuring, or do you have experience measuring from end to end, all the way to the user, or do you measure just the infrastructure?
Depends on SLA and SLO you sign. For example, you buy something from AWS. It's a global service. If they have a 99.999 service, it should be, they can only down for 5 hours per year or something like that.
Exactly, but they won't guarantee that the application is doing what it should be doing.
No, it's not the application. It's For example, if you buy RDS from Amazon, they guarantee uptime of your database, not your data or not your application or something like that.
Because I imagine it would be interesting to see what really causes the main outages. The security seems to be one of the big ones.
Yes, but for example, that you mentioned about that Sweden incidents is happening. Nobody can say not incidents or something like that. Depends on your contract. Maybe sometimes you should pay something to customer, but sometimes you have some backup plan. For example, you have another instance in Germany or something like that. You should switch traffic from your Sweden instance to Germany instance or something like that. When you choose Vietnam, since there are quite some different Helm charts and operators, they do.
My experience, it's Bitnami. They have a really good support. They have a really good security support, honestly. They have a security scan on images. They have their own Docker image. They have their own Helm chart. Also, you can, also my experience, it's if you're using an official Helm chart, for example, GitLab official Helm chart or Bitnami GitLab Helm chart, if you care a lot about security using a Bitnami, because they limited some stuff on images or on Helm chart, your hand is tied by using a Bitnami. But if you're using the official Helm chart, depends on company. Maybe they don't have it that much speed like a Bitnami, but you have a more option. For example, on the GitLab, our feature is faster release on the official Helm chart, but on Bitnami it's a little bit slow because they scan everything and it's taken a little bit time to get a latest feature. But if you care a lot about security, I recommend the Bitnami.
Have you used Zalando?
Zalando, they have an operator.
Yeah.
They develop own operator for PostgreSQL because Zalando, if you hear about that, it's an e-commerce website, but it's own operator. Also, Zalando have their own Python framework for writing operator for Kubernetes. They call I forget the name. Kopov. Yeah, Kopov. It's a Python framework developed by Zalando to write the operator. But Zalando have their own Bitnami operator. It's really good. I never touch it in production, but in test environment, it's awesome. But I hear about some of my friends, they're using on production, and they told me it's better than Bitnami Helm chart, but I can't approve. I can't say this one because I don't have experience using it, Zalando operator on production.
Good, thanks.
Yeah. Any other question?
Yeah, you mentioned
Sure.
operators being difficult to maintain.
Sorry?
You mentioned Kubernetes operators being difficult to maintain, costly to maintain.
Yes.
Care to expand what's...
Yes, for last 4 years, I'm maintaining a Kubernetes cluster on cloud, on Self-Host, on VPS, or anything. When you want to maintain a Kubernetes, you have a deep knowledge about networking, about programming, about Kubernetes, about Linux, and you have too much stuff. If let's see, yeah, you have too much piece on Kubernetes, they can break any small piece, and your Kubernetes cluster lost some of their functionality. But if you have some Linux VPS or EC2 instances, it's easier to maintain because it's a Linux. You can maintain everything but systemctl or something like that. Or if you using a Docker, it's easier to maintain because they're not that huge. But Kubernetes, it's really good for scalability and high availability system. You pay a more maintain cost. It's your engineering with your services or something like that. But if you wanted some scalable and high availability system, definitely Kubernetes is one of the best choice. You can use a Docker Swarm, or you can use some serverless approach like using a Lambda or something like that. I have experience in ViaPlay. We have some serverless high availability architecture. We're using a Lambda DynamoDB or something like that. It's super expensive, but it's easier to maintain. But Kubernetes, it's not that much expensive, but you should pay less some money if you're using a Lambda, but you should pay more money for your engineering team to manage your Kubernetes. It's based on my experience, but you see too much pieces, and pieces can be broke. You should have a really good monitoring system if you want to manage a Kubernetes cluster. But it's awesome tools. Depends on use case. If you have a e-commerce application and only have one zone, definitely Kubernetes is not really good choice for manage this. But you have a multi-region application, too many applications using too many databases, too many broker or anything, definitely Kubernetes is best choice, because that if your stack is that much huge, Kubernetes, they have some feature you can easily manage that much huge stacks. But if you have an e-commerce application or a small web application, definitely Kubernetes, it's an overkill. Any other question? I think
Here is a small gift.
Oh, thank you.
Irori. Thanks for awesome.
Thank you.
Awesome talk.
Thank you. Yeah. This is my LinkedIn if anybody wants to. Yeah.
Thank you.
Thank you. Good job. Good luck.
This works. Linux and projectors. So I should present, right?
Yeah.
And I'll unmute it all.
Yeah, I will mute.
Great. So, who am I? I was born on a farm, so I know how to handle a chainsaw and operate it, as well as a Kubernetes cluster, which is a good thing sometimes. Right now, I have a family of 5, which means that I'm experiencing chaos engineering on a daily basis. My background, it's I studied computer science at the university, and it was a lot of C++ and C and vector graphics. And yeah, I don't know if the C++ scared me away but for some reason I found my way down to the ops because I thought that was very fun to work with operational side and managing big enterprise infrastructure. And after a while, the cloud started making an emergence on the market, and I thought that was really entertaining to start working with. And that is when I came into contact with developers again. So it kind of like went full circle. So it was inevitable that I wound up working with the developers. And I thought it was really fun. So the next natural step was, of course, to step into the open source world and working more and more with those products. And that's how I ended up as a platform engineer today. My previous work was a large recruitment and staffing company. I'm not gonna say the name, but if you want, you can ask me later. And yeah, so the company, they hired me as a cloud architect in the beginning. So the job was to reduce cloud cost at first. But after a while, they enjoyed my work that I did there. So they asked me or tasked me to help build them a development platform. So that is basically where I took the turn from cloud architect to platform engineer. And I haven't looked back after. And I also worked at a large telco provider, helping build a container as a service and also to help them build API as a service within the company. And last but not least, I worked at one of Sweden's largest digital health providers. No names, but it was a really fun experience. So, why DevX? Developer experience. So, programmers, they are not engineers apparently. They like to work with programs, but they don't like infrastructure. So a lot of people, they have been thrown into the DevOps experience, but yeah, they don't really like it. So what is DevX? So developer experience. If we look on a time scale, like back in the 60s, as you can see on the picture here, it was very simple for the developers. They could focus on one language, and as time progressed, the different languages and requirements of the developers, they kept on increasing. And if we look on the last page, we can see how a normal recruitment list looks like today. So you have everything from programming languages down to infrastructure and all different kinds of products that they expect you to understand. So it's easy to understand that for developers it's going to be a cognitive overload, basically. And so it's a natural process. So we started off with ops and devs, and then from there on we went to tear down all the barriers between those and help out with collaboration. So the natural was the culture approach, that was DevOps. And from there on, they threw in security as well. They realized that that was also important. So DevSecOps was the next thing. And I would say the latest buzzword is platform engineering. So what do they supply to developers? So faster time to delivery or time to market is one of the most definite key factor. So in the early days of software development, you could have anything from 1 year to even sometimes you could see softwares that had 2-year release cycles. So you had a new version, you had to wait 2 years for it to be released. So by having a good developer experience and a platform that can speed up this process, you can change that to having releases on a daily basis. And also, if you can remove some of the cognitive load of the developers and help them to just focus on coding, they can use the rest of their brain capacity to focus on their domain that they're working on and understanding the business domain. So they can help create features and understand how they can create business value on a better aspect. So one example of that is a company that had a really good platform. Everything was automated. They have testing, and they also had the ability to scale. So you could have 10% of the traffic going to a new feature, whilst 90% went to the old feature. And on that company, they had a couple of developers working in a team. And during a lunch, they were discussing that, oh, we have all this data over here. So if we supply it to this function and we process it, we can offer or create a better offering. And because of the platform, they had the possibility to go back after lunch and do some work. And at afternoon, one of the developers had already released that feature on 10% of their production platform. And they could see almost instantly how the new feature that they had produced was generating something around 10,000 Swedish crowns extra a month just on the 10% load. So they were able to come up with an idea, they could test it, they could verify that it was working, and quite quickly they could realize and improve the business domain. And of course, you're going to have a lot happier developers if they don't have to debug why the pipeline isn't working anymore, or why you can't see the metrics coming into Grafana or stuff like that. It is subjective, but yeah, like the asterisk there. So if the developers feel they miss infra chores, they can come over to the platform team anytime. They're more than welcome. And it's also going to help with faster onboarding. So the service lifecycle management, for instance, it's going to be a lot quicker if you have a platforming team that can help out. So a platforming team, who are they and what will we do? So the main reason for the platform team is to help the developers be more productive. So They build platforms where the developers can run their applications, and they supply tools that can help them improve and visualize and see everything about their applications. And automation is, of course, a first-class citizen, so always having the automation in mind, because yeah, it is coming from the DevOps. And you should always strive for self-service for the developers. So we don't want to build in any more gatekeeping like we used to have in the olden days. So it should be that the developers can move as freely and as fast as they want to do. And a platform can also supply them with golden paths and guardrails along the way. So you can have a predestined way to do a certain way that developers don't have to invent the wheel. And you can have some stuff like monitoring, metrics, logging, and tracing out of the box. So when you create a new service, it's going to be fast. And developer experience and platform engineering, they pretty much belong very well together. So developer experience is something that I see that sits on top of platform engineering. It's something that you should strive for. And by that, I mean that as a platform engineer, you should think of the developers as your end users and your customers. And you should always ask them what their biggest pain points are and how you can help them become more productive. And you should think of delivering a product. So your entire platform is now a product, like a platform as a service. So this is the picture Eric showed earlier as well. So this is, I think, a good way to visualize the different parts that a platform team is responsible for. So you might have some segments that are owned by other teams, but as a whole, it's something that the platform should supply to the developers. You should have security built in by default, so it should be easy to make the right thing and traverse on the golden path. But security might be a different team that handles that, but it's okay as long as you have it included in the platform. It's okay. And as you can see on the left side there, you have multiple teams now consuming the platform as a service. So previously, you might have had that team one, for instance, they had instances running in GCP, and team two, they decided to go with Azure. And before you know it, you have a sprawling environment and cloud bills coming in from left and right. So today, the idea that I will showcase is very simple. It is a TLS and DNS record automation. So it's just a small fragment of the feature sets. So the prerequisite is that you have a GCP project in this case, and you have a domain with a subdomain configured in this GCP project. I'm gonna show it to you later. And also that we have the backend storage bucket that's going to be used by Terraform. So the environment is looking very simplified down here, but we have a GKE environments running, and within that one we have Argo CD running with external DNS and Cert Manager. And outside we have the cloud DNS and also the Google bucket. So if you're trying to do ingress automation manually, it's going to be a pretty tedious process. I don't know how many of you have actually been working with certificate requests, and yeah, it's a nightmare. Yeah, it's a lot of steps, and every time you do it, it's you keep forgetting how the hell did I do that CSR, and you're looking at Wikipedia and trying to read the Confluence page, and you're missing some steps in the documentation, or the tool has been deprecated or whatnot. So it's a long process, and it takes a lot of steps. And thank God for Let's Encrypt, it helped a lot, but yeah, there's still a lot of steps, as you can see. I'm not going to go through all these steps, but instead, can I move over to a demonstration? So first, I'm going to jump into the GCP project, and I can show you that the DNS that I had configured previously. So this is a subdomain that we have created, and it's a domain that resides beneath our domain, irori.se. So by doing it like in this way, we have the possibility to, within this project, have a service account that have permission to create records in this domain. So we can keep apart the real production domain from, for instance, a test domain or a staging domain, and similar stuff like that. And we also have a Kubernetes cluster that is running in here. And if we take a look at the cluster, we can see that we have it spread out on different working domains to be more resilient. And we have already deployed some applications in here. So right now we have Argo CD running in this cluster, and we also have Cert Manager. And if we go over to some more fun stuff, let's look at the actual code. So what we've been doing is we've been using Terraform to basically bootstrap the entire environment. And let's start from the beginning. So here we have specified that we want a backend state. And I don't know how many of you that are familiar with Terraform, but Terraform works with 3 pillars. You have the code itself, you have the state, and you have the reality. And all those needs to be in sync with each other to be correct. And as soon as you start working with Terraform within a team, you want, or you need to have a state where you can keep track on what has been created and what information it consists of. And we have the provider, which basically says which different parts that we want to interact with. So we're telling Terraform that we're going to interact with the Kubernetes API, and we're going to interact with Helm, and we're going to interact with Google. And when you configure these providers, you need to supply them with some information. And here you can see that for the Kubernetes part, we're actually supplying it with credentials. So we can, from Terraform, interact with Kubernetes directly. And the entire environment is being built up by these steps here. So we're setting up service accounts, we're creating or enabling APIs in GCP. And at the very end, we're using a module. So we have multiple sandbox environments that we can create, and we're using the same GKE models. So we can create, a good boilerplate on how we want to configure and set up our GKE clusters. And once the cluster is up and running, we create the Cert Manager service account, and give it the DNS permission, and then we deploy with the Helm chart, as we showed earlier. And we have 2 different Helm charts. We have the Argo CD Helm chart, and this one depends on the Cert Manager, which means that it's going to make sure that Cert Manager is installed first. And the reason for that is that we're going to be using Cert Manager with Argo CD, because we want to be able to reach Argo CD. So just by running Terraform Apply, we can provision this entire environment, and we can quickly provision a new sandboxed environment if we want to test something out or give permission or a demonstration. So yeah, and in order to get access to the GKE cluster, we need to run some commands. And by running using the gcloud CLI, we can fetch the credentials to the cluster. And by that, we can look at the namespaces that are residing within the cluster. Is it too small, or can people see? Supply glasses. But yeah, we have these are the systems that are running, and we have Cert Manager and we have Argo that are running in the environment right now. And let's have a look at Argo. So we can look at the ingresses here. You can see that it has been created. So we can just go to this webpage here. And as you can see, Argo has been deployed to the cluster, and it's using TLS. So it's already encrypted or certified by Let's Encrypt. And there's nothing running here. So the first step that we need to do here is we need to create a root application. So Argo CD has a concept called app of apps. So when you bootstrap a cluster, you can specify that you want certain services running within the cluster. You might want external DNS, or you want different services that you need at the beginning. So let's do a quick, and we do it automatic. We want to prune resources. And here we have specified some repositories. These one have been supplied already by Terraform and authorized. So the Argo CD have permission to read these. And this one is called apps. I'm going to showcase it to you. So it's basically the cluster administrator, or Argo CD admin. They decide which applications that are going to be part of this app of apps. So we decide that we want to deploy it to the default cluster, and we can throw it into the Argo. And we create this application. So what this one is doing right now is connecting to GitHub and fetching this app of apps. And show you the code. So this is the repository that it's fetching. So we have some values that we can supply. Not very special about that. But here in the template section, here we can define different applications that we want to be part. So this application, we have defined that we want to install external DNS. And we also have our demo application, app1. So what the app of apps is doing is collecting both of these information and then going out and fetching these applications. So external DNS is an external system, which is being installed in the cluster. And what it's doing is it has permission to go to the DNS zone and create records itself. So it is progressing. And we can see that we have the demo application. Right now it's running here. So it's only accessible within the cluster. And yeah, so the next step, this is, how do you say, now we've been looking at it through the eyes of if we have the infra hat, like the ops hat. And if we instead take a switch to the application side. So we want to expose this application now to the outside world, make it public. And by doing that, we can utilize all these different systems that have been installed within the cluster. So if we go to the demo application, we can look at the code of this one. So this is a very simple one. I'm using customize instead of Helm because it's such a simple application. The consists of the deployment, which is the demo app. It's just a simple Nginx running. And we have the service as well. And a service in Kubernetes is a way to load balance your application within the cluster. And we also have the ingress resource right here. So right now, this one hasn't been deployed because I have disabled it right here by commenting it out. But if we look at the ingress resource, this is everything that is needed by the developers to expose their service to the outside world. And by using these custom resource definitions, we can specify that we want Cert Manager to use the cluster issuer with which is Let's Encrypt Production, and we wanted to use Google Kubernetes engine to expose it with an ingress. And we want external DNS to register this domain for us. And we also want TLS. So there's a lot of wants, but it's a simple specification. So you can template a lot of this stuff, and you can even wrap it in a CLI to abstract away for developers if they think this is too much. But I think most developers would gladly have that. So let's enable the ingress.
Developers created that.
So we push to the main branch, which is the one that Argo is listening on. And if we can see here, we can see that Argo has already picked up. So a webhook has connected to the backend, telling Argo CD that something has been pushed to this repository. So Argo CD is then connecting to this repository and checking and matching. So it can pick up that, oh, you want an ingress being created. And here we can see that it's working on that one right now. And if we look at the events for that application, we can see it has already been very fast and actually created the certificate that we have requested. And if we go to DNS zone, we should be able to see. So once the external DNS have picked up, it's going to trigger and create the DNS records. What is happening right now is that external DNS is waiting for Kubernetes to create the real external IP address. So GCP is looking for a free available external IP. It's going to register it. It's going to connect it to Kubernetes cluster, and it's going to bind it together with this service that is running within this cluster. And once that IP address has been registered, external DNS is going to go over to this DNS zone right here and actually create it. But seems like the Americans are working hard on GCP right now. Yeah, so here you can see it has added a lot of new events here as well. So we have a forwarding rule. We have the target proxy that has been created. So that means that external DNS should have something to register right here. Maybe dig is faster.
Demo goes to see.
Yeah. Yeah, no record yet.
It's a live show.
Yeah, no, here we go. So here we can see that external DNS has been active and has already created these records for us without having to do anything ourselves. So if we now go ahead and go to this application, we should hopefully. Yeah, maybe we have the record yet. It's not in sync. Come on. Yeah, this is the reason why we should stick to just PowerPoints during presentation. I'm not sure. Or it could be a sales pitch for on-prem environments. Skip cloud. Yeah, the main take here is that yeah, it should work. We can come back to that one. So we can instead look at what is happening behind the scenes. So when we create the ingress resource, we push it to the app repository, and it has since the ingress has all these or both of these custom resource definition. That means that when Argo CD picks up via the webhook. It pulls the ingress resource, it creates it, which is of a kind ingress. And the CRD is going to ping and wake up Cert Manager and also external DNS and telling them that they have work to do. Cert Manager, in turn, it's going to be looking at the ingress resource and see that, or reading the ingress specification of the manifest and extracting what information it needs. It is then going to create the CSR, sending it off to Let's Encrypt, which in turn is going to ping back, telling Cert Manager that, hey, I want you to create this TXT record in your DNS domain, verifying that you actually own this domain, so you can't register or create a certificate for any domain. So you need to verify. That means that the Cert Manager is then going to connect to Cloud DNS, create this record, and once that has been done, Let's Encrypt verifies that this TXT record exists. It's then going to hand off a valid certificate for Cert Manager, which in turn is going to create a cert secret within the namespace that we had defined within the ingress resource. And at the same time, external DNS is going to be waiting for this ingress resource, which takes some time to create currently. And once that has been done, external DNS is going to connect to Cloud DNS and create that host record that you need. And do a quick look now. We should have it up and running. Yay! Thankfully. And as you can see, it is already TLS secure, which means that we have security already built into the application. So it's a nice way to help create somewhat of a guardrail for developers. So you could, with policies like frameworks like OPA, you could create boundaries within Kubernetes telling that you can't expose a service to the outside world without it having encryption. And you could also enable authentication within the cluster. So there's a lot of possibilities to add to this feature to keep on building a better and better product for the developer and a better experience all the time. So some final thoughts then. Building a platform for developers, it takes a long time. At the beginning, you might think, how hard can it be? I've been clicking in the GUI and creating a Kubernetes cluster is dead simple. I can do it in 5 minutes. But the problem starts immediately when you're getting questions about production readiness and you start to think about high availability and stuff like that. And backup monitoring, alerting, logging, data operations. All of a sudden, it becomes really nuisance. And also, you need to have most of your infrastructure defined as code. And the main reason for that is that you have a quick way to create it again. And if you need to make some architectural decision or change, you can quite quickly destroy and recreate your entire environment. And also, a main key factor of having infrastructure as code as your main or default policy is that if you want environments to be as similar as possible between development stage and production, you can define it with Terraform or similar tools like that, and just have some small variations. So you can have micro instances for development environment, for instance, but you can make sure that the same code is being used in all the different environments, which doesn't trip you when you all of a sudden deploy it to production and it doesn't work. But when I say having most of the infra as code, I would say that you should. It can be easy sometimes to get stuck in the idea that everything needs to be one command deploy. So you try to create everything. You have some wrapper bash scripts that are doing some extra stuff and whatnot. And all of a sudden you realize that you've spent an entire day trying to solve a problem that only exists once when you deploy an environment. And it's something that takes 2 minutes to do in the GUI or similar. So yeah, I really like this shot. I don't know if you can see it, very small, but it's telling you pretty much how you should balance and think about it. It's from XKYC. And yeah, exactly. So yeah, I really recommend it because sometimes you spend way too much time trying to automate something that really doesn't need to be automated. So it can be okay to have like multiple steps that you deploy this first, then you wait, and then you have this other Terraform code that you go in and you deploy that one. So I think that is something that I would hint at. Another thing is cloud agnostic. I've seen a lot of companies going on different ways. I've seen going all the way into SaaS, and I've also been working on some teams or customers where they have cloud agnostic as the #1 priority. And I think cloud agnostic is very fun. And yeah, when you have that mindset, you always need to think when it's okay to use a PaaS and SaaS service. So, for instance, MS SQL as a PaaS service in Azure, it's very nice to use because trying to manage all that stuff yourself, you need to manage licensing being deployed to the virtual machines and whatnot. And before you know it, you realize that you're spending way too much time compared to the price that Azure has pressed down on that. But yeah, it's also quite easy to, if you want, for instance, to move away from Azure in the future, it can be easy to actually deploy a virtual machine, install MS SQL, and just migrate the database. That means that, yeah, it can be easy to change a cloud if you want. And yeah, and a lot of people say, how often do you change cloud? Yeah, not a lot of people do it, or not a lot of companies change providers, but seeing how they bump the cloud bills, I think we're going to see a lot more cloud exits in the future, and a lot of more companies moving away from American companies and stuff like that. And having a cloud agnostic mindset when you build a platform in the first place makes it a lot easier to just move your entire infrastructure. And the staffing company that I was working for, we had cloud agnostic as the #1 priority because the CIO had been burned previously by AWS and their bills. So he wanted to be able to move, and they actually did an exit from Azure, and it went nice. So they cut their cloud bill by half almost by just changing cloud provider.
Wouldn't it make more sense to just stay on-prem than to, I mean, if you have that fear?
Yeah.
I mean, the question, I guess, is how much extra work is it to be agnostic? But it's probably quite a lot if you're not a big company.
Yes. So it's the last bullet here: build it or buy it. So if you're going for SaaS and PaaS products, you're basically buying it, but if you're looking at it, you're basically paying Microsoft or their engineers for building that PaaS product or that SaaS product. So you're paying premium. So instead, you can decide, yeah, we're going to put an extra engineer and we're going to build it ourselves. And the main benefit of that is that you can customize it any way you want, and you have the possibility to be set it up in an agnostic way. So it's something that you can move quite easily. And yeah, our final thought is, when are you done as a platform team? And I would say never. If you consider a platform as a product, you're always going to find ways to improve. And it's going to be a key factor is going to be having interviews with your developers and the different development teams, trying to figure out what are their pain points, how can we create a better product. And if you think of the platform as a product, it's a natural way to talk to the developers. That's about it. Any questions?
I have a question.
Yes.
Super nice presentation. I mean, talking about platform as a product, it's like sweet music to my ears, which I guess you already know. But I'm kind of curious. I've seen, I mean, you basically want developer teams to be able to own cloud resources because they can manage to themselves.
Yeah.
And then you're like, you have this big, shared Terraform repo. It's scary. Or we have Terraform scattered everywhere and no one really knows what. Or people like, oh, crossplane, we should do crossplane and everything's going to be great. What would you pick if you got into greenfield projects and why? When it comes to like, how would you manage this? And I'm talking about non-Kubernetes resources. You most likely need buckets and whatnot outside of Kubernetes.
All those extra resources that are sprawling. I would try, as a product owner of a platform team, I would try to figure out what all the teams have as a pain point. If there's only one team that has a problem or trying to fix something, that is probably not going to be the main benefit of the entire company. But instead, if all the different teams are having issues with creating bucket and handling buckets, then I would spend some time to create that for them and abstract away and try to help them create like a good baseline. So yeah, I would take it into creating a feature within the platform to supply a bucket as a service within the platform team.
And if I would force into that, I take you as my advisor. What would you pick as your first tooling choice? Sorry for being so cheesy.
No, I would definitely try to have it the ownership within the platform team to make sure that the developers are mainly consuming, or so they don't get how to say, deviated and trying to figure out fancy options. And yeah, because it can be easy to grab a specific product, but if you're going down that path, it's also that you're choosing the PaaS product, for instance, from Azure. They have a thought out way on how you should work with that product, and there's quite often you notice that there is a golden path that the development team of Microsoft had decided, and it can be that they want you to use Azure DevOps, for instance, or it could be a different tool chain. So yeah, they want you to be within their entire ecosphere. It's in their best interest. So they're going to make that their product is going to be fitting really well with the other components that they have in their cloud, because they want you to use all their SaaS products. That means that you're stuck forever and ever, and you're basically you're sitting in their lap. And when it comes to talking about the bill and deciding at the yearly basis, you don't have any bargaining options. You're basically stuck, and they can basically see us. Yeah, they're using all our SaaS and PaaS services. They're stuck. So we're going to bump it for 10% extra this year. Yeah.
Similar question. If you had a free choice in a greenfield setup, would you opt for public cloud or on-prem, and what would be the main reason?
I would probably go for cloud at first. But the only reason for that is that you have all the, I would say, the tools present to create environments, to scale quickly and test stuff out. So the team can move very freely. Working against on-prem environments like VMware or stuff like that can be quite tedious. You need to be on VPN and stuff like that, and you need to have Bastion host setups. So there's a lot of hinders along the way, and you could have like a firewall team that doesn't work with you. They try to work against you because they feel that they're threatened, because you want to do all this fancy stuff. You want to introduce service mesh or stuff like that, and they don't trust that at all. So yeah, I would definitely go with cloud at first, but build it in a way that you have some clear interfaces. So you have easy way to separate and replace different products. So if you have a clear interface between, I would say, you build up a virtual machine and you build on top of that. So if for instance, you want to be agnostic with Kubernetes, you could build virtual machines. And virtual machine is something that you can get from anywhere. You can buy it from VPC like Hersnu Cloud, or you could get it from an on-prem provider. But
it sounds like it's a bit like going on an all-inclusive vacation versus taking your Jeep and traveling the world.
Yeah, but I would definitely go with the
And
cloud,
maybe it's
cloud
nice
first.
to start with the easy vacation. The first time.
Yeah, definitely. Because if you then in the future want to move back to on-prem, you have had an easier like developer experience, because at the beginning when you're working in the platform team, it's going to be a lot of plumbing being done. You're building like a house from the ground up, so you want to be being able to move as freely as possible and as fast as possible, because you want to be able to destroy the environment. For this for the staffing company, we had a principle that at the end of the day, we run Terraform destroy on the entire environment. That made sure that at the end of the day, we reduced our footprint on the cloud, and the cloud bill didn't cost anything. So we only had cloud cost during the day when we were actually working on the environment. And it was also a good way to verify that we had everything defined in code as well. So every single morning, we ran Terraform apply, we built up the environment, and we kept on building on that. And while it was building, we went and grabbed our coffee. And when we came back, the environment was there, and we could continue building on the different parts. But we kept building in modular patterns, so very Unix philosophy.
And you secure that you use the cloud in an economic, optimized way.
Wow.
Yeah.
That's a good question.
Yeah, I would say you would definitely need to supply the tools for the developers and at the end. So keeping track on how much developers are using. So for instance, if you're having Kubernetes, I would give the developers a view pane with the observability. I would give them the tools to show how much their applications are using. And one thing that we did was at one customer, we created a Kubernetes dashboard where you could see all the resources in the cluster, and you could have sort of resource shaming, you could say. So we had a top list of the most wasteful pods running in the cluster, so we could easily see which team there were not utilizing. So you could force them to look at their application, and they could see with the metrics, they could see that their pods didn't use as much, and they could go in and change their workload to accommodate for the amount that they were actually needing. That helped a lot to create bin packing and reduce the cost, so we could have fewer instances running. No other questions?
I'm not sure I dare to ask them. It's like, I guess I can continue that one. I think so many companies right now are like rebuilding a developer platform as a product, and we do internal developer platform interface, and we do handling cloud resources and whatnot. When do you predict that we're actually going to agree on? Because what we all do is like read the container, we ship it to Kubernetes, and in the end of the day, it's not that different, but every company builds the...
You have these 5 tools that you're using all the time.
Yeah, but we put so much resource into that.
Building it.
Yeah, and there's no like competitive advantage of what's done there. It's a necessity. I mean, of course, they're committed to some extent.
Yeah, I think...
majority of the companies, this is not where they differentiate.
No, I think if you're searching around on the internet, you're probably going to find a PaaS service that are supplying this already. But I think the main difference that a lot of companies want is that they want to have insight and control and tweakability. And that is the thing I think a lot of companies are afraid of. They want to be able to adopt the platform or customize it to match the business requirements or the business flow of the company. And I think how companies work differ quite a lot. But as you say, I think we might see more packaging in the future with the same tools. I mean, Argo CD is almost default. Like Kubernetes have basically knocked out all the other container providers, or sorry, not but container runtime. So you hardly see Docker Swarm anymore. There are no tool sets around it anymore. And yeah, Nomad is very slim. There are some edge cases, but some companies use it. But yeah, most people, they go with the bigger ones. So same with monitoring and metrics. Prometheus Grafana is the default stack in most cases. But yeah, I think it might be a natural evolution of the next step to actually package it. And I think it's something that going to be working a bit on also with this sandbox repository that we have, that we're building more and more modularized to help like bootstrap. So in most cases, we have some differences. It might be that a customer that are using Azure, they might be using GCP or on-prem. So we only need to change the underlying infrastructure. So if we have this interface that I was talking about, we only need Kubernetes for this level. So one level might be that we want virtual machine. The next level is we want Kubernetes. And if we can have code for that, we can bootstrap quite a lot. And it can be easy to boilerplate a platform environment for a lot of customers.